Hi, good evening. Can you hear me?
Hey, I don't know. Yeah, yes, I can hear you.
Great, thanks. I was not sure if Zoom setup is something that I'm not using daily, so I
Yeah,
wanted to
same here.
test it
So,
out. Wanted to test it out. I wanted new tool download and so on and so forth. Thank
yeah,
you for thank you for joining. I hope we have enough quorum today. I'm not sure. It somehow I was on vacation last week, and for some reason the scheduling took up ages. I don't know. Still don't know what happened, but.
yeah, I also don't know. I mentioned it yesterday in the SDSM call, so let's see. A few people from there will probably join. Hopefully, some people from the Kernel side also join. So,
Yeah. In any case, I think I can kind of, when we get to it, so I have like just two slider to kind of, introduce the kind of, the problem and kind of explain. So, and I think meeting is going to get recorded, so we
yeah,
can,
I think the recording is already on. So,
yeah, so people can kind of watch later.
but then also send an email to the Linux Coco list. That should get the attention of the kernel people at least, I think. Or I hope so.
Yeah, I sent to invite to Dave Hansen and Tom, and so let's see. But it was, to be honest, it was in a short, like in a couple of days' notice. So now it's because of this kind of strange scheduling. So
Yeah.
let's see.
But the
It'll be
scheduling
fun.
now is much better than it was last year, where one session was Fridays at 6 p.m. and the other was like, I don't know, at 2
Something
a.m. in the
like,
morning.
yeah, in the middle of the night for us. Yeah, I was complaining to Dan, but even the Europe friendly, slot is not quite Europe friendly. But yeah.
Yeah. But I think with this time slot I can attend more regularly. So
Yeah, me too. So for me, it was like 9 or 7 p.m. or 8 p.m. Friday. So it's like, ah, I think getting my people. It's still give a couple of minutes. Hi, everyone.
Hello, hello.
I think Steve is supposed to run this meeting, right?
Right. I
Yeah,
think
he's
so.
not here yet.
Hello, can you hear me?
Hi, yeah, I can hear you.
Yes, we can hear you, Stefano.
I wonder if anyone knows how to ping Steve, or should we start without him? Or
I don't know. Let me look up the mail thread that we had.
Yes, James, Zoom is painful, I agree. That's why I started like 5 minutes before to make sure I'm connected in time.
Oh, you didn't do what I did, which is try to use my Microsoft laptop, realize it didn't have the Zoom app installed, couldn't download 128 megabytes of stuff in time, and then had to fall back to my Linux laptop.
So I don't know where Steve is, and I wonder if I should start without him, or I was not prepared to run this officially, but here's Steve. Hi, Steve.
Hey, Elena.
Okay, so you can then chair this. So I was just not sure if you're joining, but I am prepared to present the topic, which because I asked for it in agenda.
Sounds good.
But I don't know if I guess you want to, kick it off. So. Do you want to do any,
Oh, sorry. I had muted myself. This is a huge mistake. I was talking to the void. Before we get started, I just want to make sure that you have everyone that you need here. Otherwise, I'll just introduce.
Well, we have quite a number of people, so everyone that we need is kind of a bit stretching, and also because of scheduling, this was pretty late and wide. So, but I think it's good enough that we can start discussing this topic. I'm not expecting us to be done in one session anyhow, so it's better to get started.
Cool. Yeah, hi all. Welcome to the Linux kernel SIG meeting. Today we're talking about, I believe, SVSM and its guest OS interactions, which I suspect will be a pretty substantial topic. Let me, now that I think about this, I should probably click. Do we need to click the record button? Nope, we're already recording. Great. And I will actually, I guess, hand off to Elena to introduce her slides and talk about things on that front.
Let's see now if Zoom shares. That's another problem. Just a second. Share.
If you want, we could lend you a BBB instance. This would work a whole lot better than Zoom.
But anyway, now we have to manage with what we have had to get rid of all this stuff. Anyway, can people see what I'm sharing?
Yes.
Yep.
Excellent. Okay, so I only have 2 slides because I really wanted to be discussion, and the 2 slides is really just to make sure everyone is on the same page, and why do we talk about this topic, and why do we talk about it now, and so on. So to start from the State of the Union, so I think all of you here this call are aware that both AMD FSMP and Intel TDX, they support this concept of dividing the confidential computing guest into kind of separate execution environments. On AMD FSMP, it's called VMPL levels. In Intel TDX, they're called partitions. Kind of different naming, different architectures, but somewhat similar concepts. So both of them have the highest privilege level, VMPL 0 on AMD and L1 on Intel. And then, this is very, but kind of the VMM or the parallelizer, I don't want to go into this distinction now, or basically for us, Coconut SVSM is going to run. And when there is, non-VMPL 0, how I call it here, and L2 guests, this is where, the OS is expected to run. We actually user OS. So this is given. And then on AMD side, AMD has a while back, and I put a link here, published the specification which defined an SVSM protocol, which is essentially a protocol for interaction between this guest OS and the VMPL 0. And in AMD, I'm not, of course, entirely familiar with it, but to my understanding, it's kind of used for, both for core functionality, some memory and vCPU management, as well for attestation things like both native attestation and VPTPM. And in addition to this protocol, there's also implementation already for Linux, which lives under Coco and SF specific. I mean, I put here code.c, but it's somewhere there and around in Ceph specific code. And on Intel side, the reason, so we do have the same kind of concept of partition, kind of division of the guest OS and the paravisor, but the reason we haven't defined yet any similar protocol is primarily due to architectural difference in how TDX partitioning is implemented. So and very kind of, I don't want to go too much into details, but just to give you an example for what kind of things I'm talking about is that, for example, for TDX, if a guest which is running an L2, so in this non-privileged partition, executes any TD call and TDX is actually like a call to perform a certain action inside of confidential guest, let's say accept a page or obtain the the native attestation report. So when it performs it from the L2 guest, this results in what we call kind of L2 to L1 exit. And this is like a special exit in our case. In a sense, it's kind of virtualized, but it's relatively cheap exit. It goes from L2 to L1. It kind of goes through TDX module, in fact, but kind of, its experience is like we would exit kind of to L1 at the end, and there's no exit to the host, so it's relatively cheap. And because of this because of this defined behavior, if you have something like Coconut SVSM which resides in L1, in principle, it can emulate any required behavior with it once. Let's say, if a guest issues to the call to accept a page, or it gets this exit to L1, and L1 can inspect what kind of page guest is trying to accept, and make a decision. Does it want to issue real accept call, or drop request to a floor, or whatever it wants? It's really in control of virtualization. So and this would have been really primary reason. So for the core part of this is what, like, that I'm using the SVSM protocol, we really haven't seen a need for it so far. And as well, like native attestation as well. And the VTPM story was, I think, discussed quite extensively in mailing list. In principle, we could do it, but I think with first implementation, I think proof of concept which Jivan was posting was actually using the native MMIO for and for communication with TPM. But this is not a TPM kind of discussion, so I don't want to go there. So anyway, so this has been the state of kind of things so far. But now, I think it was like end of last year in discussion, I think it was discussed in SVSM call, there was a new use case raised and specific to the Coconut, and kind of, I think Jörg can explain more, or and others like more familiar with Coconut with details, but like as I understand it, it's kind of use case of observability. So basically the tenant is runs in this in our case in L2, it must be able to get access to some kind of information from about Coconut SVSM, like console logs, runtime information, memory management, available services, and so on. And this use case, it's kind of only, it only exists. So this only makes sense if you're running an L2. So if you're running as a plain guest and partitioned guest, you don't have Coconut SVSM, you don't need it. So you obviously don't have anything to query or so on. So this is now specific. So this breaks out of this previous logic where we try to keep everything unified and say, okay, our interfaces from both unpartitioned guest and guest running an L2 is the same. Now we're saying, well, okay, there is a use case where the guest actually needs to communicate to L1 or SVSM, and it doesn't have like kind of existing means of doing it, unless they go, and there is this caveat here, unless we think that this can be done like what I call here native Linux way, Virt.io and so on, some kind of, we try to find existing interfaces which kind of can support it. But if we kind of, and this is also for open for discussion, what people think which way is right, but if we decide that yes, we need some kind of a SVSM style protocol, and remembering that this is already kind of implemented in our in AMD's FSMP code, if we want to make the implementation common, we clearly would need to think of common abstractions, because we can't start merging similar things into RX86 Coco TDX. So And if we go that route, and we can discuss if we want to go that route, it would be great to kind of have a discussion of how this would look like. So at minimum, it seems like we would need some kind of hooks to detect, both for joint hooks to detect, SVSM presence, hooks to send receive messages using SVSM protocol, and of course an underlying transport stays vendor specific. So for Intel and AMD, it's going to be different. But this is basically all I have from slides wise. So I just really kind of want to open it up and kind of what do people think about it? So how kind of how realistic is to have this abstraction, and do people think this is useful? And yeah, any other thoughts or comments? Let's just
I think we should start from whether we can reuse anything that we already implement, rather than making SVSM protocol generic. Virtual seems like to be a feed, but it would require a lot of enabling on Coconut side, if I understand correctly.
Well, wait a minute. VirtIO is basically a bus discovery protocol, and it includes a messaging interface in it. The SVSM interface is really nothing other than a messaging interface. I don't really get why you see there's this huge difference between them.
So procedurally, I want to ask a question. I heard you guys complaining at the beginning that you're having problems with Teams, so I don't know if you can see hands raised.
Oh, I don't even know it.
Yes, I can see your hand raised.
Okay, I have my hand up. So
it's this stupid Zoom thing. I only see your hand raised if I'm actually on the square of the window, which includes 4 people that has you on it. Other than that, it doesn't tell me anything.
All
And
right.
I'm as a presenter, sorry, I don't see anything. I don't know.
Okay, well, that's good to know that hands is not a useful protocol in this forum. Do you mind if I say what I wanted to say?
Sure.
All
Go
right.
for
I didn't
it,
want to derail Kirill here, but so I want to make a couple of points. First of all, you point to the use case only exists if running under Coconut SVSM. I don't think that's true. In fact, today we have this notion of privilege separation when we run Linux as a confidential guest on Hyper-V. We did everything using proprietary protocols, and so there's a bunch of stuff in the Hyper-V drivers that exist in Linux. But the concept of enumerating the capabilities that you can find in the higher privilege level is a very common concept. It's like we rely heavily on it when we run our proprietary, actually, we have a proprietary higher privilege level. We're moving towards OpenHCL, which does the same thing using the same Hyper-V driver protocols. And so this concept of enumeration is going to keep appearing over and over again. So I wouldn't say like, oh, well, Coconut SVSM has showed up and now we need it. It's a common concept. It's time for a common protocol. I think we also need to think really hard about separating the how and the why aspects of cross-privileged communication. The SVSM protocol that you pointed to really couples the how, like how do you get into the SVSM and pass information. And it couples it to the why. Why are you going there to ask questions? But we have to talk about them separately. The why can have different meanings on different platforms. Once privilege separation exists in SEV-SNP, for example, there's a bunch of things that the guest is simply not allowed to even attempt. And so the core protocol defined for SVSM includes a bunch of functionality that is necessary as soon as you boot the guest out of the highest privilege level. That's not necessarily true for TDX, but the notion of some architecture-specific conversations will exist. But there are plenty other examples of things that have nothing to do with the architecture, but simply the presence of some kind of higher privilege level, whether it's Coconut or OpenHCL or something else, where you need to be able to ask, what are you? What can you do? How can you describe other services that I need to understand so that I can interact with other relying parties, et cetera, et cetera. So if we're going to talk about how we achieve standardization, I think we want to be very clear about keeping that dividing line crisp, recognizing that calling conventions certainly have to be architecture specific. Some aspects of the protocol will have to be architecture specific because like the p-validate call is meaningless on TDX. But some other questions like, is there a virtual TPM in you? That's a question you need to be able to ask, and doing it in a standard way is reasonable. Do you have logging information that I should digest because I should pass it along to some other service? That's an interesting question. How do you handle VirtIO? That's an interesting common question. So I think we want to start not by saying, how do we hijack SVSM and make it common, but rather, how do I identify a set of cases where there is commonality in the questions that you want to ask, and then from that build up. How do you go create a transport for it?
Yeah, so I fully agree with SVSM. Like as we look at does this go actually? Why doesn't it go to a back page? But if we look at the SVSM as how it's defined, like on that previous slide where I had the IMD pointer, indeed it has like both definition of essentially a transport and even like what I would call application layer protocol, like VTPM and so on. Even p-validate to me is kind of for the application kind of style. But here I think like first, that's why I put this kind of beginning very small. So, detecting the SVSM presence or whatever is that paravisor or, that privileged entity which we are running, and then hooks to kind of, basically send and receive messages. And that can be beginning. And then we can think indeed, what is the common functionality? If we go this route, what is the common functionality that we will need? And again, I guess logs would be common, clearly. VTPM would be common, maybe something else as well.
But it sounds like the first question that you wanted to answer, where we don't yet have a consistent opinion, is, do we want a standard? And I think what you're getting at, and certainly what I'm saying, is yes, we want a standard because there is a growing number of examples of cases where there is no architectural way to contemplate what a higher privilege level is. There's no PCI register, there's no instruction, there's no whatever that you can trap and emulate and get it right. You have to find a way to ask, are you there and what are you? And what can you do? So maybe I'm all by myself here, but I think we can already assume consensus that we need to have an answer. Does everybody else agree with that?
Yeah, I think I agree with that, but the question of why you think VirtIO is different from the SVSM interface is curious to me. I mean, if necessary, we could re-wrapper the SVSM protocol up as a virtual bus, call it SVSM bus and just do everything like that. I don't think that's a good idea because the proliferation of all these stupid virtual buses is annoying in hypervisors because every different hypervisor has a different one.
Yeah, I don't know that I was trying to make the claim that VirtIO is the same or different.
Well, no, I was going back to the slides. The slides
so,
say...
So I think so kind of I gave VirtIO as one example, but kind of the common, I was just trying to think like the common objection thing when you're trying to introduce something new is that, okay, can it be done using existing means? So this is like, because otherwise everyone would want to bring all kinds of new protocols and things. So, and these things have to start to multiply like, like rabbits. So,
like virtual buses.
Like virtual buses, right? So that's why I'm saying that like we have to have a strong case to say that, okay, why this is different and why this cannot be solved with existing means.
One thing I will observe is that when I wrote the SVSM document to begin with, I wrote it with the idea of extensibility, that there was a set of protocols that is inherent to how it works, but then there's a set of protocols that you can just discover and they each do whatever they want to do. And right, the assumption there is you can define a protocol that is not that is not tightly bound to SVSM, but simply as a description of a set of calls that you can make, like an interface. And I think we have a lot of options to say, how do we define a protocol suite that has common meaning across SVSM and other platforms, but the calling convention is architecture specific? I think that is entirely achievable on top of SVSM today. And we can say, great, let's go figure out what the TDX calling convention looks like. And now let's go build protocols so that the way you pose the questions, the way you form request blocks and so on is identical across platforms.
I'm not so worried about like TDX defining a protocol. We can define a protocol if this is, a decision and direction that community wants to go to. It's more like, I would like to hear more like core Linux people opinion, like, like, is this realistic to kind of, I mean, everything is realistic as it's just code, but like, is this a good idea to take, and have this abstraction basically in RGX86 Coco and I guess the IMD code somewhat needs to be changed to use it, but that's again not a big issue.
Is there a better idea?
could I ask a different question? I mean, if we didn't do this for TDX, what is the alternative? Because right at the moment, you say you work via instruction emulation, which can be done in most cases, but there are lots of things, and we got one, which is observability, that can't be done by instruction emulation. And so that seems to imply that we always need some type of interface between the higher and the lower privilege levels to communicate stuff that we can't do via effectively as device or instruction emulation. Is that a true statement, or do you think you can do it via device or instruction emulation?
I mean, I guess you can do it if you really want, whatever it would be the right way of doing it. That's a kind of
But
question.
you
The
have to
other thing you
invent
need to
something
be-
new. Go ahead, Tom.
I was going to say the other thing we need to be aware of is that some of this stuff is used very, very, very early in the boot, right? So relying on some kind of device emulation where you're going to need some kind of driver in place isn't really going to work, right? So you need something that, and part of like compressed boot, right? When we accept memory, right, we need to do p-validates, and so we need to do something incredibly early during the boot process.
Right, but that's
right, but
I wouldn't
that's
use-
for that's for AMD. So we don't
I-
have anything which needs so early boot.
I wouldn't use p-validate as an example for exactly that reason. But if there is something you want to discover, you have to ask how. If you say device emulation, then where is the device? Is it something that shows up in PCI space? Now you're emulating a PCI device ID. Is it something that shows up elsewhere in MMIO space? Now you have a contract for what magic MMIO addresses you use to discover this, or IO addresses, or whatever they are. Like there's some sort of discovery contract, which is your bootstrap. And I guess yes, you could invent anything you want, IO space, MMIO space, something else. It just seems to me that you would like to do something on AMD. You would like not to have to invent something because we already have something. And on TDX, building something that is specific to the TDX architecture as your bootstrap seems like a more reasonable starting point, so that you can then build an abstraction that sits on top of both of those things for all the common cases, like observability.
The device emulation model also only really works or only makes sense in the paravisor case and not so much in the SVSM case, where because
That's it.
if you have an enlightened OS with an SVSM underneath, then the SVSM has a hard time emulating a device. So right.
That's an excellent point.
Right. I don't know how much like TDX will support that way, but in principle, since it can architecturally support both, yeah, it would be nice not to be tied to this limitation.
I guess what I keep hinting at, but I haven't really come out to say, is the ideal model is a layered model in which you have at the lowest layer a communication convention, which is ISA specific. And then at the higher layer, you have a protocol that defines the format of messages. And I guess I would advocate that the higher layer be architecture independent. The lower layer must be ISA specific. At the lower layer for AMD, it's advantageous if we can use the existing SVSM protocols because they're already there. And I don't really see a reason that you couldn't use the existing SVSM protocols. TDX would have to invent something, but TDX is going to have to invent something no matter how you do it. And so inventing something that acts as a great foundation for this common higher level message protocol seems like the shortest path to commonality.
Yeah, and I just come back to the idea that this is just really another bus. That's all we've done. And I mean, you mentioned that the Linux kernel hates device proliferation like this, and actually that's somewhat true, but we can't get away from it. Every time we get a new boot standard, even for x86, we always come up with some new way of communicating information across an API boundary. That's all really the SVSM protocol is. I mean, it's not like we don't have hundreds of these and we won't get hundreds of more. So I really don't see that proliferation is a significant problem as far as at least the Linux kernel is concerned. It annoys us, but we cope with it.
And I think following on to what you just said is, you're faced with this choice of do you add a new one or do you try to build on top of an existing one? And trying to build on top of an existing one, there aren't any obvious choices that work, especially with the constraints that like some platforms needed early in a boot before there's device discovery and so on.
Well,
So
actually, let's go
isn't-
back to experience. Usually, trying to add something under an existing one causes all kinds of cock-ups. Look at what happened with UEFI when we tried to use the old BIOS interfaces, for instance.
Sure.
Everything just exploded underneath us. So realistically, if something is new and genuinely new, chances are having a new interface is an easier way of handling it than trying to shoehorn it into an older existing interface.
So I hear you advocating, let's not try to go couple ourselves to something that already exists that is only halfway usable and that will require a ton of compromises that we're not happy with. Let's just go build the right thing.
That's pretty much it. I mean, what I'm really saying is I think the device proliferation horse has bolted from the stable decades ago. So it's just a question of what is the easiest straight line route for getting all of this functionality easily enabled. And it sounds like not having to build device emulation inside the SVSM is a great plus from York's point of view. So if we're only left with instruction emulation, I can't see how the hell we do observability like that. And therefore, the only thing left to us is this Coconut SVSM protocol. And if we use that, it also gives us a nice way of doing some of the virtual devices like a TPM, even if TDX doesn't want to do it that way. It's still a useful way of virtualize or sort of doing VirtIO stuff.
So, and I think if you follow that path, which at least to me seems entirely reasonable, then the question is, do you take a clean break from what was done with SVSM today and say this is entirely new for all platforms? Or do we say we'd like to avoid excess proliferation within this niche confidential computing set of code, and let's see how much we can take advantage of what already exists to avoid creating more noise? And I think my opinion, which is not strong, is you can build this on top of SVSM on AMD. You just need something else for TDX, and that's probably the best starting point, but that's not a strong opinion, and there may be a better way to do it.
Well, I mean, the only thing the SVSM protocol needs is an exit to guest with exit to higher privilege level with a flag that says, "Hey, I got a message for you." That's really all it does. The MSR and GHCB protocols.
Sorry, I'm noticing-
transport is light here, so it's
I'm noticing Diana has her hand up.
So as a part of exploring how we could get the VTPN supported, I wrote a TEE device driver for SVSM that could be just the way that SVSM gets invoked no matter what. So it does have a good enough abstraction using a TEE device so that you can just have a session that has shared memory and invocations that communicate using that shared memory. And if you're using TDX or SevSMP, the specifics to the communication buffer setup and context switch are pretty cleanly kept within the TE device.
Wait, it sounds to me like what you're describing is kind of like what I was saying before with a layering model, where your code sits at the higher layer and the TEE device is just this lower layer transport that takes care of the nitty-gritty of message passing. Is that a fair summary?
Yeah, so TEE devices exist already to do things very close to what we're trying to do. Like Microsoft did the FTPM on Trust Zone. And we have basically a virtual TEE within a VM by having an SVSM.
In this case, the lower level protocol is not a TEE per se, but it's a communication primitive to a higher privilege level. So thinking about it as a TEE driver is probably not quite the right model, but I think it's the idea that you have a lower level driver and a higher level need, I think, is a good way to think about it.
But I mean, to just consider it from a design point of view, let's say John totally screwed up and the SVSM protocol breaks down at some point later on. Does it really matter that at that point we throw it away and reinvent something else? I mean, we do this all the time in physical systems anyway. So it's not like we have to plan this hugely magical, infinitely extensible thing. It looks like what we've got is good enough, and we could just use it today. And then if at some point it proves not to be good enough, we can find something else.
I think that
And-
there's kind of a proliferation of the calling convention specifics within Linux right now. So you would need to put it behind something like the TEE abstraction so that you can cleanly replace your invocation method.
Well, but I mean, you could say the same thing of the FPTPM, the firmware device that KVM uses to communicate information from guest to host. I mean, we already have, and Hyper-V uses a slightly similar but slightly different thing, as does pretty much every virtualization system out there. This is nothing really than an extension of that, and those don't slot neatly into the TEE spec. Now, you could say that actually we should standardize the whole lot of them, and there are lots of people in the Linux kernel who'd be very happy if somebody would step up and do that. But trying to herd all the cats at the VM manufacturers has meant that it's always looked like a Herculean task. That's why I don't really think it's just important to do it rather than try and find an existing mechanism we can slot it under.
I mean, we're meeting here. We can start.
Well, I get,
okay,
James, I think
that
the summary of what you're saying is we could spend a lot of time trying to figure out what's perfect. Why don't we just try to get something working and then use that as the straw man that we can criticize and either embrace or throw away, or, depending on what actually gets built. Let's look at some actual code and see how far we can drive it.
Yeah, I think so. This is the Linus Torvalds approach. Perfect is the enemy of the good.
Right.
I'm curious about one thing you said, Diana. You said that the TEE interface needs an ACPI something or other, and I didn't quite get that. I thought it was discoverable on its own.
So the FTPM is implemented as a platform driver, which means that it needs to either match a device tree or ACPI tree, or ACPI table, in order for it to get probed.
But why can't the FTPM subsystem in Linux probe it and add a platform device? It doesn't need an actual described device in terms of either ACPI or device tree. Because basically device tree doesn't exist on x86, so that means we have to muck with ACPI tables, which is an incredibly unsafe thing to do. Well, it's not unsafe, it's just annoying and difficult.
It is annoying and difficult. I've been trying to figure out how to do it for several days now.
I also think that if we have to, just on your TPM thing, if we have to mangle ACPI tables, you might as well do it as a CRB interface. The CRB has everything it needs anyway. That's how Intel did the TPM initially for their proof of concept SVSM.
Is the calling area already a CRB anyway?
Yeah, CRB has a buffered calling area. It's got 2 pages for send and receive, if I remember rightly. And it also, the main objection to using that for AMD was we couldn't tell. It uses a bitmap bit-bang interface, and we couldn't tell when that bit had been banged. But if we're going to modify ACPI tables, we can do an ACPI start method, which is actually also how Intel did it. So, I mean, it obviates the need to do anything else if we do it that way. But I'd still rather not tamper with ACPI because of the difficulty of actually doing that.
The other challenge you have to think about with ACPI is there are only 2 places to construct ACPI. You do it in OVMF, and you do it in the host. If you don't trust the host, you don't want to take its ACPI table, so you do it in OVMF. Where does OVMF get the information it needs to figure out how to get itself off the ground?
Well, no, we could do it in the SVSM. I mean, what we do is we take the host tables, vet them, and add our own entries, then pass it up to OVMF to do its thing with. It's possible to do it. It's just messy and nasty.
Yeah, I'm not clear on how OVMF gets those tables if it doesn't have a protocol to get them over, but I'm sure that can be invented.
They're passed through the so on KVM, they're passed through the firmware config device. which obviously would then mean that SVSM had to speak the firmware config protocol, and we've just invented a whole new way of interfacing with it.
Yeah, but now you need the SVSM protocol has to be extended to have firmware protocol in it so that it can then go and ask what the SVSM protocol is. It sounds a little circular to me.
Well, it sounds nasty to me. This is why we don't do ACPI in the SVSM.
Yeah, right.
But assuming that we want to go this path of the common protocol, so what I want to discuss a tiny bit where people think like what would be the right place for this, at least like for this base abstraction to live. Is this like, under x86 core we try to define this abstraction? Because I certainly don't want to try to put it like, I think it's not right to put this kind of into the driver or anywhere. So, because now there's this a lot of discussion about the drivers, but
the entry method for the protocol is always going to be architecture specific. So whatever that is, it has to sit under the Arch x86 and then even the AMD or Intel subsystem for that. And we can probably persuade the ARM people to do a similar thing.
Yeah, but I think Elena's question is for the common layer. Where does that live?
Yeah, the common layer, not the entry point.
I think if the goal is that we have a common code in the Linux kernel, and the Linux kernel already has the SVSM protocol implementation, is probably the SVSM protocol specification is probably a good way to start and derive a generic protocol from that. Basically, I don't know, removing the core protocol or something, making that AMD specific, and but other than that, using similar mechanisms that would then allow to basically move the AMD SVSM protocol specification or protocol implementation in Linux into a more generic part of the code and make it reusable by TDX. So
let me ask a more specific question that I think is getting at what Elena wants to understand. Suppose we need to add a function called collect paravisor logs. And that is going to go formulate a request that gets passed over some architecture specific channel. Where does the body of collect SVSM logs live? Can't be architecture specific because it's common. So where does it live? x86 Cocoa? Somewhere else?
I think it should be under drivers.
Yeah, a separate driver, or is that option also?
Drivers TEE, SVSM TEE.
Yeah, that's probably a separate driver that basically provides a user space interface and translate that to calls to the observability protocol. So I think it would live under drivers in the driver section of the kernel.
So basically that lives in driver, and when the driver talks to our x86 core hooks to actually do the messaging, unified hooks to send receive messages using the communication protocol, and when that drops to vendor specific down, right?
Right. Having generic code under Arch x86, which basically does the SVSM discovery, which then of course in Arch x86 has callbacks to AMD and Intel code because discovery is different on those platforms, and then having generic functions or a generic API to basically do the calls and pass messages that come back and things. So and then have a driver under driver that calls into this code.
But now a question I have with this, like, okay, so this driver would be, let's say, observability driver. So do we try, and then next we figure out we need some other drivers for some other use case. So do we partition these things into separate drivers, or do we try to have a drive? Sorry?
Sorry to interrupt. Continue.
No, just to say, do we kind of keep partitioning this per use case, or do we keep define a generic, well, not generic, but some kind of SVSM driver, which would support with different use cases like observability, something else, and that something else might or might not be available depending on the actual, even potentially
I think we partition
vendor.
by use case. That's always been the way in the kernel. I mean, let's say for some reason we needed a confidential data store in the SVSM and we managed to get one, we'd probably have a storage-like driver for accessing that, and we'd put it under the standard storage system because that already exists. So it's driven by the use case.
You can also assign a UUID to the trusted application that is to extract the paravisor console logs and use the TEE interface to invoke that function and get the response out.
Any other opinions or thoughts? I'm just trying to collect options so that I can kind of try to summarize this later on. So it looks like everyone thinks use case, or, and then I guess it's, yeah, it's how do you?
Yeah, it's hard to extrapolate what will come along in the future, right? So, but I think with the split approach, we are on the safe side. We might end up with a collection of very small drivers. But yeah, that's also not a big problem, right?
I guess the driver kind of has a benefit of that, you know, I guess we can make it like, okay, some drivers like observability, I suppose it's, you know, applicable for both architectures kind of. I could imagine there could be drivers which only used, let's say, only on AMD or not Intel. I don't know if we will have such things, but I guess this would also give that flexibility, right? So if we try to shuffle everything in one driver, it would become kind of messy, likely.
Right. We also have the option to use a mixed approach, right? For example, doing everything that's SVSM specific, like observability into one driver, and doing things that are not really SVSM specific, like a TPM interface, for example, into another driver, which already has other drivers because we have TPM drivers in the kernel, right? But
yeah. Actually, I meant only SVSM specific things. I didn't mean to try to shuffle the rest, like services into services, obviously separated. But like I was wondering, like, you know, anything which is SVSM connected, should it live in one driver, or do we want to have SVSM, you know, dash observability and SVSM dash, I don't know, some future use case and so on?
I don't think we need to do that. I mean, we already actually have AMD specific drivers in drivers. There's the one for the SEV-guest interface, for instance. I mean, we already know how to do this. It's the SEV-guest interface.
Oh. Well, we have also the TDX one, but it's different.
Dan Williams came and said that SEV-guest was a mistake and should have been behind configFS or sysfs. So it's still hard to add more ioctls.
Well, the problem with, I mean, ioctls have gone from being loved by everybody to hated by everybody to loved by everybody. There's unfortunately always a use case for adding ioctls to these things. And I think Dan also admitted in that conversation, which was over a year ago, that there were cases that we couldn't. So he wanted to do this TSM driver or sysfs-based TSM or the configFS-based TSM thing. There were use cases that SEV-guest had that the TSM couldn't cover because it was restricted by the way configFS works. So there would always have to be at least a small number of I/O controls in SEV-guest anyway. Now, nothing precludes us from figuring out a better way of doing something like the SVSM interface, but it does make sense to start from something that we know and something that exists today anyway.
Let me ask another question, like in case someone has an opinion. So what could be, so I assume we try to go this direction with the, unfortunately we don't have like all the maintainers I would love to have in this call, but so what could be the objection to this? So that we could, you know, try to think and brainstorm the ideas, like what would be our reasoning? So, you know, they said one common objection is, you know, we already have means of doing it, or, you know, don't invent something new. Can people think of more objections? So that, like, you know, the reasoning is more grounded when we submit something like this.
what I would expect to be raised is the question of why this can't be part of config.fs TSM.
Yeah, I think that's also was kind of my thinking with. I don't know, like it feels strange to do something like this to me, like personal over config.fs, but I'm not so savvy in this too. Well, I don't have strong opinions. I don't know.
Yeah, the question, well, we don't know what all the future use cases will be for this interface, right? So it's hard to say that config.fs TSM will be able to
Actually, I
handle
think we can.
all of that
So
or not. So
config.fs has trouble with bulk data transfers, and from what I get from the observability driver, it's going to be spitting out quite a lot of bulk data in the form of logs, right?
yes.
Right, so that's probably an argument for why it's not going to fit well into config.fs, but that doesn't mean there isn't something else in the Linux kernel it would fit nicely into for bulk data transfers, for instance.
Do other architectures have similar interfaces? There are architectures where the default is that you run under a hypervisor like S390 or sometimes even PowerPC. Do they have some kind of such interfaces that provide observability to the software running underneath?
Yeah, they all have the debug interfaces, but most of them run over the debug console IO port, which is a really nasty and slow interface for getting stuff out.
So no real interface to the guest itself or to the OS itself.
Well, yeah, I mean, the debug IO port is an interface from guest to host, but it's a VM exit per character type interface. It's not ideally suited for bulk data transfer either.
Yeah, okay. And the Linux kernel
To
is
answer
probably
your
not.
question, there have been attempts to do this before, but none of them I would hold up as a shining example of something we should follow.
Okay, yeah, that was what I was trying to probe. So there's nothing similar out there yet in the Linux kernel, no interface, which this would fit into.
I can't think of one.
A virtual console is somewhat, but it's yeah. I mean, if we're talking just about a console, but all the overhead it's.
Yeah, previous observability interfaces have basically been just get it to be good enough to get some data out, and then we just stick with it. That's what we've done with the debug interface for virtual machines, regardless of how inefficient it is.
Yeah. Well, I think I could come up with a few more use cases to probe against that, against whatever protocol we can come up with. So, or whatever interface we can come up with in the kernel.
So I think we're getting close to the top of the hour. So maybe the last kind of question to ask, like for this initial session. So what people think could be the next steps? So what's the right way of starting this discussion? You know, I suspect in order to get like, you know, people, I don't know if let's say if we schedule, but I think we need like, I mean, the basic kind of place it's going to touch is x86. So we need x86 maintainers here. So do we try to make a schedule on our call? Do we start welcome
I think
discussion?
we just need to bring a code and start from there. It's better way to bring attention to the topic if you have code in hands.
In general, I would also like to see an explicit list of questions that we haven't answered or things that we haven't settled on. I'll probably start a thread on the Cocoa mailing list trying to accumulate things that we don't have total agreement on or we're like slightly unsure about, basically to try to make sure that we have a focused set of questions that we're actually trying to answer here. Because yes, we have other action items that are out of band for like, hey, we need to grab these people to ask them things or settle on particular issues. But I would like to make sure that we settle on, one, agree on what we necessarily want to do long term, but two, also identify the things that are unsettled, because I feel like we've talked about a lot of things and we haven't necessarily concretely settled on any individual bits. Not that we necessarily have to, right? But I would like to see.
Yeah, I don't think we can. So it's like
yeah,
it's not
exactly.
it's not up to this limited group of people after all. So
yeah, exactly. But like we don't. I think we've gone through a bunch of topics. I want to make sure that we agree on what even the topics are that we're trying to settle on.
Okay, so you're saying that we should send a summary to the Cocoa mailing list, right?
I will start a thread. I will send a summary of what I'm aware of from this, but I would like other people to contribute because I will almost certainly have missed topics. I don't actually want to go back through and watch this hour-long video. I could do that if the people feel it as necessary, but ideally.
No, I think yeah, if you just kickstart it, so we can keep adding things.
And I really like to vote for getting some of the x86 maintainers into the discussion before we actually write code, because in the Cocoa world on Linux, we have to write enough code to get everything running, and spending time on something that will probably not go upstream and it's just a base for discussion is.
Yeah.
I'm not sure if it's a good use of time, right? So
this is also my concern, because this is intrusive enough where it would be nice to get a direction check early.
So I would suggest that we tell to the x86 maintainers, here's what we discussed and this is the route we like to go. Do you like it, or do you have another? Can you point us into another direction or something? So that's what I would like to try before we actually get down and do a prototype or something.
I would agree. So Jörg, do you think you could start with email, or should I do this, or how do we do that?
Ideally, we invite someone to the next call. Yeah, I can reach out to a few people and see what the best way to discuss this would be. So maybe it's a thread on the mailing list or group chat somewhere. Yeah.
That would be great if you could do it. Is that I tried to invite at least Dave, and but I don't know. It's also said the scheduling for this call was pretty much last minute, in my understanding. So yeah, I don't know if there's kind of if they could make it, or what's the point.
Yeah, as I said, I will reach out to them and then see where this gets me. So
thank you. That sounds great. Let me stop sharing. I think, like, at least from my point of view, I think this is a good meeting. So I don't have anything else from my side. I don't know if anyone else has anything.
Cool. I think that's everything then. Thank you all for coming. I will follow up with an email attempting to bring up some of the topics, but then also asking people to summarize other things that they want to make sure that we talk about in the future. And thank you all for coming.
Thank you, everyone.
thank you.
Bye, everybody.
Bye.
Thank you. Bye.